So today we're going to talk about SKIE, and I've been giving this demo for some time. We've been working on SKIE for quite a long time, and actually I want to thank the entire Touchlab team. It was an enormous amount of effort. I think we're going to have some content talking about the effort involved in SKIE at some point in the near future. Very special thanks to Thaddeus and Philip, who done really amazing work, but frankly everybody, and a lot of the marketing team and the business folks, everybody. It was an enormous amount of work. It's kind of hard to explain. We started it earlier on thinking that it would be a relatively straightforward thing to build, and we were going to add features as individual modules and things as time goes on, and then as it turns out, one of the things that we learned very much the hard way is that you can't really do it as feature modules, because all the features, like if one thing adds a couple of new functions and then another thing does something to your existing functions, like they can't work in isolations. They have to know about each other, because now you got two functions and the other thing has to, so the complexity is not linear, and the happy path is just that. It's quite straightforward and happy. The sad path, or the edge cases, let's say, are surprising, never fun, and seemingly, although becoming less and less common, but never ending. Sort of some weird calculus limit. Anyway, but we got through it, and I mean, to give you a sense, there is in our various pieces of wild code, there is one of the testing suite. There are multiple testing suites. One of them downloads every public library for KMP that is remotely still runnable, because some of them haven't had a release in a couple of years, and it runs it through SKIE. So every commit, it does 1,000 plus libraries. It's pretty wild. We've also discovered that once you get to that level, you're much better off renting your own box than trying to use GitHub Actions runners. But let's not talk bad about GitHub Actions. So it was a long journey to get here. Now, we released the tool, and it is, and what it's basically doing is pretty straightforward, right? The Objective-C output from Kotlin is not ideal, let's say. I gave a talk at Kotlin Conf where I was talking about what makes Kotlin Multiplatform different, and to give you some insight into my brain, it's why did I become obsessed with this particular technology. People ask things like, why not Flutter or React Native or whatever, and I'm like, those are entirely different things. The philosophical makeup of the technology is focused on sharing logic, and primarily, in particular, focused on the interop. And it's a long philosophical discussion about why we don't share code much, or traditionally in the native mobile space. And I've been, it's fair to say, obsessed with this question for some time now. And there are a lot of aspects to it, but one of them is the interop. Like if it's difficult to call other code, the more difficult it is to call shared code, the less likely you're going to use it, right? So some examples I've given recently are, if you're building an app with some machine learning in it, and you're doing something pretty aggressive like that, and you've got, data scientists and they just work in Python, that's all they work in. You're not really going to take that code and rewrite it in Kotlin and Swift just because you're putting it on a phone. You're going to have some kind of virtual machine running in your thing, because that's what you got to do. But if you're going to save a key value store like preferences, you're not going to try to write that in C and communicate with it, right? The likelihood of using shared code is dependent on the distance and the resistance and the difficulty of doing so, and there are several aspects to that, but one of the major ones is the interop. So the interop for Kotlin Multiplatform is amazing, and I put an asterisk next to that, which is relative to everything else. And Kotlin outputs Objective-C, but if some people are often, especially when this is presented to an iOS team, they're like, well, it's Objective-C. I don't like it. It sucks or whatever. And so the problem is often framed as, if we can just do direct Swift interop, then this is fine. But it isn't that simple. I've been saying that for some time, right? Like, it is going through Objective-C, which does have an impact and strips away some of the modern language features, because Objective-C is not a modern language. But then Swift and Kotlin, although syntactically similar and trying to solve similar problems, they do so with very different structures. So what comes out of Kotlin is not going to just become something that makes sense to Swift just because you can get rid of the Objective-C in the middle. So what SKIE is doing is taking a step back from the technical details. It is attempting to make opinionated transformations and decisions to bridge Kotlin to Swift and maintain important structures. That is its fundamental goal. Now, we have talked to many teams. This is kind of what we do. Sometimes people ask what we do. I'll tell you exactly what we do. We help people make stuff. Sometimes it's Kotlin Multiplatform. Sometimes it's full apps. And we've been an app development company for quite some time. And if you are looking for help, God forbid, with some apps or some Kotlin Multiplatform, certainly, or really to get started on the right foot, which is a lot of what we're doing now, and configuring and helping teams really make that investment. Anyway, that's what Touchlab does. But we spend a lot of time talking with many teams, and one of the things that we did found, especially when we started building SKIE, is a lot of teams that are using Kotlin Multiplatform successfully obviously have to deal with this interface, and sometimes they just get used to working around it, and they know where the foot guns are, where the pits of failure or whatever, and they just try to have policies to code around them or avoid them. And some teams that are a little more aggressive will write wrappers around things. So they'll add enums or do something with steel classes or whatever. Then we found a handful of people who actually wrote automatic generators, which was quite interesting. We found many more people who started and then wound up not deploying them. And I'm not saying that to like make fun of them. We fell into the same trap where it seemed really straightforward until you got to your first edge case, and then your second edge case, and your third edge case. So we found that a lot. So it really became apparent that this was something a lot of people wanted. And to walk further down the future path, people ask all the time, like, what happens to SKIE when Swift interop comes out? And I don't have a clear answer right now, but just because your Swift is directly hooked up to your Kotlin doesn't mean that you get sealed classes. You just get classes, unless the Kotlin compiler team decides to make some opinionated choices, which we spend quite a bit of time talking to them, and hopefully will influence their future decisions. Be that as it may, here we are today. So, what does SKIE do? What is SKIE? When we launched, we had a lot of stuff around SKIE that was in the launch materials, and my only going back in time thing that I would say is I really would have liked to have made the SKIE demo a little more obvious and prominent, because the SKIE demo, although it kind of seems just like a random throwaway project, we've been using this for a while to show people on calls, like, what is SKIE and what does it do? And having spent years trying to do tech talks and sort of demos, and then now obviously the last few years everything remote, it is a trick to show people code on a video call and have them not like eyes glass over and completely lose them. And SKIE is an API level tool. So one of the issues we actually ran into with SKIE's release, which I think it's coming out today or tomorrow, we're changing Camp Kit, which, if you're aware, is our beginning project, is sort of turning into a reference project, which going back a few years, if you wanted to learn how to do KMP, good luck. It would be, multiple long dissertations on Gradle, yada, yada. And we built CampKit is like, just clone this, run this, and then you can start learning incrementally. Well, now there's a bunch of those. I'd actually give a shout out to John O'Reilly. It's like, if you want to see a sample, he's got everything you could possibly want to touch somewhere in one of his repos. So CampKit's kind of morphing over time. But anyway, CampKit is getting SKIE. We were going to lead with that as the explainer for SKIE, but the problem is CampKit is also trying to address architectural issues and thinking through things, and there's actually a whole layer above the API that we're currently embroiled in discussion internally and on Twitter and kind of all over the place. So CampKit can have SKIE features, but it gets confusing because it's doing other things. So there's conflicting problems that we're trying to solve. The SKIE demo is just here's the thing and here's what it does exactly. This is absolutely not how you'd architect an app. That's just an FYI. My dog is in the background. He's in a cone. It's been a long few weeks for the dog. So I'm talking longer than I planned because we had to switch streams and I didn't know if everyone was going to get here. So hopefully I've given you time. So now we're going to sort of enter the formal part of the demo, as formal as I get. Anyway, so the SKIE demo is an application that is absolutely not how you'd architect an app. It is just very, very bare bones Swift UI calling into some Kotlin code, and almost a complete lack of view models or any of that stuff for the purposes of being able to show exactly what the API does and little else, as little as we can avoid. There are two basic parts to SKIE and to this demo. Which the first part is essentially type augmentation. And the type augmentation does some things that are very, critical parts of a Kotlin API that you kind of lose when you're doing KMP that everyone pretty much wants to add back, right? And that is enums, but like exhaustive enums, proper enums, and seal classes, which if you get over to Swift, seal classes just become classes, and default parameters. But I'll get into that. I should follow the demo script rather than just freeform it here, but that's kind of how I roll. In any case, there's two parts: the type augmentation, and then the man. This OBS software is interesting. All right, anyway, so you get the type augmentation, and we also have the reactive interface. The reactive interface is, coroutines into async structures in Swift. But let's jump into it rather than having me just go off script. So I'm going to switch to this desktop view. Hopefully that is... Yeah, it looks to be appropriately sized. I'll get rid of my camera if it becomes a nuisance and is pointless, but we'll see. So, this is the SKIE demo sample page. Please go hit this up and play with what I'm going to show you now if you get a chance. And to SKIE, to the sample, to Cambridge, which we're going to release a new version maybe today, maybe tomorrow, and we're going to have another live stream next week. Try to keep the correct URL that time, but anyway, any of these things, please go and hit the star button if you've got time, because it helps us prioritize our efforts, and it sounds odd, but it actually helps figure out what we're going to focus on and budget time and effort. So it actually helps to get stars. It's not just vanity. So please do if you like what we're building. So. We're going to do the SKIE demo. As mentioned, the SKIE demo is not how you'd architect an app. It is very, very simple. We're going to show the type augmentation part first, and the primary goal here, and you'll find this kind of theme as we go along, is it's not simply just adding parts to the API. The goal is when you get into KMP, and this is one of the misunderstandings I think people view it, is that, well, I know Android, I know Kotlin, so I'm good. and the reality is there's quite a bit to learn, just the basics of what's going to come out on iOS, but also, especially with the interface as it is out of the box, you have to learn what to do, what not to do. You have to have a sense of what it's going to look like from the Swift side and what the experience is going to be like. And that affects how you're going to design APIs significantly. And if you're not really well versed in that, you're not going to find out something's bad until someone tells you, kind of thing. So SKIE's goal is to make some of these pain points something you don't really have to worry about as much, or you don't have to worry about at all, depending on the context. That's its overriding goal, is to make writing the APIs easier and to make consuming them not just more pleasant, but like more type safe, more expressive, and all that kind of stuff. And I won't really get into the philosophy of it, but there was a whole layer of API design for KMP to expose it to iOS. That actually I'll talk about it next week in the stream, because we took our original Cambridge Kickstart thing, and part of the API was we wrapped all the callbacks with this special API iOS wrapper and all this stuff, and you can kind of toss all that stuff and just have your Kotlin API with coroutines, with seal classes, with state flows, just pushing data out of there, and you can talk to the same thing from either side. So yeah, I'm going on a bit long. Oh yeah, one little thing before I forget. Presentation. That should hopefully be good enough. Let me do presentation large, just because we'll see how that goes. So this is the demo. We're going to run it real quick. The first thing we're going to show is just a calculator app. It is not complicated. The user does stuff on the screen, and it does what you'd expect the calculator to do. So we go over to here, and the first thing I'll show you is in the Kotlin code, we have some basic types. And here we have an enum. We are passing in a string from the user's input, right? Like, they're typing it in, but the idea is you could also, enter it, whatever. And whatever the user enters gets passed into here for parsing to figure out what it is. So here we have this lookup entry type function, and that takes a string, and it's either going to return this is a number or it's an operation. Those are the two options. Not too complicated. Then we get to the operation type, which is a bit more involved, which is a seal class, which I think now we're in Kotlin 1.9. This is going to tell me data object, I believe, but we're just not going to deal with that right now. Anyway, seal class. And this represents the type of operation you might be doing with a calculator. So we've got the basic stuff, plus, minus, divide, yada, yada, and then an error state called unknown with a message that tells you what happened. And then, again, the front end is going to call into this with this function, and it's going to pass in the value the user typed in. We're going to have a default value here, which, spoilers, you don't get. Anyway, and then we go through and it returns whatever you would expect it to return. So that's all that's doing, right? So if we go back to the thing here, we have the computation function class. This is sort of a data model here for the UI. The Swift UI is not exactly important. We'll pay attention to this. So as the user is typing in stuff here, we have this input function, and that takes the string that calls our Kotlin enum lookup with that input, and we get an entry type, right? And then we go down here, it just does something with it. It'll do a switch statement, numeric operation, and then default, right? Because they're not exhaustive. Then we come back up here, and if it's an operation, not a numeric, we have to look up the operation type and get that seal class. And again, to highlight, you have to pass in the default value because you lose default arguments or parameters or arguments. I always get those mixed up, but you know what I'm talking about. They're not there anymore. And then with that value, we call handle math operation. And that also does a switch statement. Now, seal classes to Swift are just classes. They don't mean anything other than classes. So we have to, check the types. And then, again, we have to have a default because it's not exhaustive. And obviously, we're always going to correctly have all of the options in there. So if we find something we didn't expect, I just failed the app, which is not what you should do. But obviously, you see where I'm going with this. So there's kind of a forest for the trees thing here, which is like the interface isn't great, but that all works. You know, this all functions. It'll do what you need it to do. But the SKIE situation is let's see if we can make that better. So what I'm going to do is go back and go into the configuration here. Now, I would say if we add SKIE, but for the purposes of the demo compiling properly, SKIE was already in there, but we had intentionally turned off SKIE's implementation for this particular package, so the one with the enum and the seal class. So I guess it's a good time to point out that if you are migrating existing code base, we have a migration guide which talks about how to do that. And you can do it by package, you can do it by feature, you can do it by feature globally, you can do it by feature by annotations. There's a lot of options. But anyway, we'll go in here and we'll comment this out and we'll get this to run. And this, of course, is the scary part of a live demo where we got to wait. And thankfully, these newer machines, OBS can run and it can compile and it's not going to take forever. See, it was even shorter than I thought. So this works and SKIE is run on it. But now if we go back to Xcode, we're going to scroll down and notice something, right? We got a warning. It's just a warning. It's not a big deal, but what it's telling you is this is no longer necessary because we have exhaustive enums. Now, how do we have exhaustive enums? That's easy. This is no longer a Kotlin enum. This is now a Swift enum, a proper Swift enum. And what SKIE does to enums essentially is it generates real Swift enums that match the Kotlin enums. We rename the Kotlin enums with underscores to hide them from autocomplete, but they still exist. So you can hide things from Xcode's autocomplete, but they're still there. And then in the header transformation, there's a little bit of movie magic happening that essentially automatically transforms these between Kotlin and Swift. So if you return a Kotlin enum from Kotlin and you call that function from Swift, you will get a Swift enum. You don't have to do any transformations. You don't have to be aware of it, right? Like this is returning a proper Swift enum now. The type has changed. For enums, this is often a drop-in replacement. You don't need to do anything. There are certain edge cases to be aware of, but for the most part, you can drop it in. I won't go deep into the edge cases. Don't worry about that too much. It usually works, but they're not that big of a deal. And part of the issue here is you'll find out at compile time because it'll tell you we can't compile, and you can go figure out what's going on. So that was a warning that told you that, but that's fine. The next thing, you don't get any warning about this, but we do have these back. So we have the default parameter here. We don't need to pass that in. Oh, wait, did I not? See, this is going to get me in trouble on a live. It is going to get me in trouble on a live thing. I will attempt to rectify that in a moment. We now have default parameters disabled by default in the newest version. This is what you get for updating right before the call. Let me see if I can rectify that. I don't want it there. I want it here. No, I want it here. Wrong one. Yeah, there is an issue with, because there are default arguments kind of all over the place, that if you just turn it on globally, there can be a lot of places you don't expect them, such as data classes and all these things that you never are going to call, and it'll generate a lot of extra code. So we wound up very recently turning it off based on feedback, actually. So there we go. But hey, you know, sometimes these things happen. I hope that rebuilt. Let's see. Cross your fingers. Okay. Good. It worked. Woo. All right. Anyway, yeah, I think I opened up the old demo, so we're going to be fixing my old demo live. Lucky everybody. So we get that seal class now, and we go down to here, and this is the function where we're doing a switch statement over the seal class. Now, seal classes do not. They're very similar conceptually to enums with associated values in Swift, but they do not translate well directly. Again, happy path works okay. You get even slightly beyond the happy path, and it's kind of a nightmare. So that's not what we do. What we do is we generate a set of enums that are in parallel to your sealed hierarchies, and there are some nesting possibilities as well, which I won't even go near today. But we generate this function called onEnum and pass it in the sealed class, and that will return an actual enum that you now have to use here. So this is no longer a class, so we can just do this, right? And we're checking actual enums. Some of the types are a little long. We actually just released we're on 0.42 in this demo. We released 0.5 yesterday, but there was absolutely no way I was going to try to do 0.5 on the demo. Just bear with me. Yeah, and the other thing I think is I need to make these lowercase. Yep. So things that have changed in the last couple of releases. We did a lot of stuff right before we went open source, and I think I am in the old demo. Sorry, everybody. They're going to tell me I should have rehearsed more, which is not untrue. So Xcode thought about that. We got rid of the default, and it said something's wrong, and we realized that we forgot our friend unknown. So this is a brief moment to talk about obviously the type safety of using seal classes and exhaustive enums, but also talking to teams who are writing wrappers. Wrappers are great, except in this kind of case. Like if you forget to add a new case to your wrapper manually, like you're still going to have the same problem. So obviously automatically generating things is good. So anyway, we get to print unknown. And if you recall, we had some data in our data class, and gee, we would love to have access to that, which you can. So we put that in here. You can grab it if you need it. It is also not the parent type of operation type. It does cast it to what you would expect, and it has autocomplete on the data. So that is essentially what the type augmentation does. There are other things where there are some function renames, some things are cleaned up. They're sort of in the docs, but the broad strokes of that. You can actually use seal classes with generics fairly well, which in other contexts kind of doesn't work out really well. So if you were going to have maybe some kind of generic infused result sealed class type where it would be loading error or a success or result, and then you would have a generic type in there that all comes across real well. So they're actually quite useful. Going back to our Kotlin to discuss if we were to add this, what you have to do is add SKIE to the module that's exporting an Xcode framework. And SKIE will automatically detect that you have Xcode frameworks in there and do its thing to them. So in place. And so you don't need to change how you're deploying anything. You don't really need to change how you're building anything. If you're pushing binaries somewhere and somebody's grabbing them, you don't have to change how that works. And what happens is it does a compiler plugin that does some IR transformations, a little other magic there like in the header I was talking about, but also generates actual Swift code, and then steps into the Kotlin compiler and compiles that Swift code against the header that was produced for Objective-C, and then links it directly back into the framework. So this all happens within that pipeline seamlessly, and all you have to do to get that to happen is just add this. Now it will add a couple features, or most of the features globally, again, except for default parameters. So you can control that here, and it is very important if you are migrating a code base that you're aware of that, because it will change types, right? We attempted to have as much as we could drop in source replacement, but they're not the same. It necessarily has to change type. So if you just apply to a large code base, you're probably going to have some issues. So you should do it incrementally. And there's recommendations in the migration guide about which features are more or less likely to be problematic. So that is what SKIE does. I'll step out in front of some of the questions. Oh, by the way, we're going to take questions, but it's going to be in the chat, and we're going to kind of wait to the end. Hopefully we have some folks on the internal side watching the chat to pick out anything that's super interesting that comes out while I'm talking. But, we'll have questions at the end and see how it goes. So, anyway, we're going to move on to the second part of the demo, to the reactive layer part, aka coroutines interop. Now, going back to the purpose of SKIE and the general design guidelines, we really want to be able to write your Kotlin APIs. You won't be able to write them exactly as you might write them for just some Android client or some other Kotlin client that is perfectly compatible with everything. But the goal was to really make the broad strokes, the big important stuff that you're going to use. You can just use it directly without having to think through it or write a lot of adapters, or even more so on the Swift side, to not have to do anything that is extra or very custom. Like we really didn't want to have any extra ceremony on the Swift side if you could avoid it. We wanted to make it seem like you were just talking to any other Swift library as much as feasible. And for the person that's writing the Kotlin API, we wanted to remove a lot of that like cognitive load and frankly training that's necessary to understand how to avoid the things and change what you're doing and all that kind of stuff. So the coroutines interop essentially it does two basic things, which is it allows it ports flows over to Swift and it exposes them as async sequence instances, which is part of Swift's async stack. And then for suspend functions, it exposes them, but it does so in a way that does not have any thread restrictions, and is also supports cancellation like out of the box. And for as far as the flow part's concerned, it automatically participates bidirectionally in the asynchronous life cycles of these various platforms. So to Swift, a flow appears as an async sequence, and it acts as an async sequence, and it does nothing you would not expect it to do. So going back to the demo, we will get to the first part. First part is this tick. Tick just counts up. Tick is very simple. We're just going to show basically how flows work and give you the general vibe of what you can do with that. So we'll go over here to our reactive package, and we have tick provider, and this is just a global object that you call this function ticks. It returns a flow of unit, and it delays for a period defaulting to 1 second, and that implements the timing that you see in the front end, right? The front end just calls that, and it gets back a thing, and it does stuff with it. Over here, we have a demonstration of ticks without SKIE, so we intentionally disable the flow interop. And again, you can see how you can do this, fine-grained with annotations. Like either you can turn off flows entirely and enable them in each one, or the other way around, which is what we're doing here. And again, default argument interop here, which I neglected to have on the other thing. So that's what happens over there. Oh, also there's one thing to point out. On start and on completion, we have lifecycle events from the coroutine to show you what's going on. So you'll be able to see these, come out in the Xcode log. So if we go back to the tick demo here, we'll go to the Swift UI, and the Swift UI is not super complicated. We've got the view, we've got the state object, which is just doing some stuff. We'll talk about that in a second. And then the body here, and all this is a text view, which is exactly what you saw on the screen. It's a little thing that's counting up. And then we have this task modifier. If you're not familiar with what this does, essentially it is when the view appears, this gives you an async context within which to run things attached to the view's lifecycle. So when it shows up, it does this. When it leaves, it cancels. So we're going to call our activate function in here. Down here, we've got, just some state, which is the string which we're setting. We have this activate function, which we're running in the main because we're in the UI, but we don't have any other thread restrictions otherwise. This is going to get our flow, and it's going to loop over the flow essentially, and then every second just update that state, and the UI gets updated. It's important to point out here again our attempt to not have any extra ceremony that is specific to Kotlin. So this is the entirety of the Kotlin that this class, the Swift, is touching, right? And to Swift, this ticks, which is a flow in Kotlin, is an async sequence, a proper async sequence. So it, as I mentioned, also participates in the lifecycle automatically. So you'll notice that this onStart, which came from the Kotlin, was actually called when I open this. When I leave, we're going to get on completion. And that's because when I leave, the async context from Swift gets canceled. That propagates to flow, which gets canceled in the way that it should. Then it would work the other way if it got canceled from below. And if you go back here again, you'll see onStart, and we start the whole process over again. So this scan function is not part of the Swift set of things, the official. It's not something that we wrote. It's a third party, which we included, one, just to use it for what it does, but two, to make it abundantly clear that you can use Swift designed asynchronous libraries. It is a full Swift, full-fledged async sequence. There's nothing special about it. And we get down here, we're going to loop over it and, do the thing. So I'm just briefly looking at my notes here to see if there's anything I got to talk about. And yeah. Oh, the quick thing I wanted to show is if we go to the function that, first we'll show the one that is the one that we call, let me say shared, and ticks. And ticks has this type, which is actually SKIE Swift Flow, which is an async sequence, but it's SKIE Swift Flow. We have subtypes that are specific to state flow and shared flow and other ones, but it also carries along the generic information, which will look more interesting when we show you the next demo. But if we go down to, and also we have the default parameters, so you can see there's two possibilities here. If you go to ticks without SKIE, we actually get just the interface, the core flow. I've once seen someone attempt to collect the interface of flow on the iOS side by hand, not in a library, and it is rather unusable. So that is essentially what we're trying to rectify here. That's the tick demo. If we move over to the other one, we'll just kind of restart this just in case. I don't know why. We have this thing called Solo Chat. And it is called Solo Chat because it's a chat program that pretends there's a server, but there isn't one, and we just write messages to ourselves, right? So, hello, oops. Does not like Colmac. Okay. Click a button where you have an artificial delay, and then a message pops up in the list, right? So we'll go over to the Kotlin. This is a more interesting example of flow and asynchronous interactions. We'll go into the chat room and talk to the data. I'm just going to briefly look over at the Slack just in case there's any emergencies. All right. I don't think there's any emergencies. I have my notifications off. Pro tip, if you're going to speak publicly, especially if you're going to show your screen, turn off your notifications. So going back to our Kotlin, and I had the place. Okay. So we have, this is the chat room. It is, sort of a view-ish, it's more of a repository-esque model. Still trying to figure out where, quote-unquote, view model lives in the shared stack, but that's a digression I won't get into. Anyway, mutable state flow, which is just a list of strings. And that's private. This is a pattern that should be common to a Kotlin developer doing a lot of flow, state-e things. We expose a public version of that, which is just, we're just casting the private version into something that's immutable, and that's a state flow of type list strings. Then we have a suspend function, which we call, and we delay, pretending there's a server, solo chat, and then we just append this to the state flow, and then flow does what flow does. We are also going to show you what happens if you have the suspend interop disabled. This is, spoiler, a more dramatic demonstration of what SKIE does, which can be fun. So we go back to Swift UI, and we go to the chat room demo. Now, this UI has a bit more in it than tick. It's not just a text box, but you know, we have the parts, and we go all the way down, yada yada. We don't have to go into detail, but the same thing. We have a task modifier that calls our await. Down here we have an actual Swift view model. You know, we're just calling it that, but whatever. Inside here, we create an instance of our chat room from Kotlin. We have a bit of, we have this state, which is an array of strings, because when you go from Kotlin to Swift, lists become arrays. This is going to be the state that Swift is showing. And we have some purely UI state, just the draft and the thing that manages the spinner. We get down to here, and we have the activate function. And then again, we get our async context, and we can loop over the async sequence. And as new lists are emitted, we just assign them to our state, and the UI updates, right? There are some things to point out here that, again, this is going to be something that Swift actually understands fairly well. It is an async sequence, although we call it SKIE Swift state flow. And again, this has a special type. I'll talk about that in a second. But one of the important points to show you here is that the generic type information is retained, and it's appropriate. So it is, we're returning a list of strings. We have an array of strings here, and obviously this is going to be helpful for Swift developers to figure out what's going on. And we don't need to do any casting here or anything special. Yeah, a quick aside about it's a state flow. Well, it's an async sequence, but we actually also add some things that are useful from a state flow. And oh, that's right. I was like, why is this not working? Chat room messages, we have a value which you can read synchronously, just like you could in a state flow in Kotlin. If you made it a mutable state flow, you'd be able to set it there too. Just some sort of nice usability additions that you may want to be aware of. So that's what that does. If we get time, I'll talk a bit about future plans. And one of them is like, you know, how do we expose a piece of state that you can watch rather than looping over a thing and changing it, sort of like, you know, compose, you know, consume the state or whatever. It's in the works, but, you know, one thing at a time here. So send draft. What happens here? You click the button. We're going to send something, right? And again, main actor, because, you know, it's the UI. And we just call our chatroom.send, and it sends the message, you know, I guess, again, just to remind everybody what's happening. You know, we do this and click the button, and it clicks, and it goes. So, again, we have extra support for suspend functions. They support cancellation, and you can call them from any thread as a reminder. So first, we're going to show what happens without cancellation. At some point, I want to have a better, like, visual demo of cancellation, but just bear with this one. It's clear. It's just you have to watch what I'm doing. So right now, what I uncommented is we're going to start a new task, and we're going to call send without SKIE. That is the one where we turned suspend interop off in Kotlin, and we're going to send it a message draft. And then immediately afterwards, we're going to call cancel, which should shut that down. And then, you know, await, and then we call the actual suspend method. You can take a wild guess what's actually going to happen here, and I think you'd be right. We're going to see TWICE, or is it L? Yeah, Colmac doesn't really work out on this keyboard. Anyway, we got 12 twice, which is confusing, but you get the point. It didn't cancel. That's the point. So what we're going to do here is just make a real quick change to say, let's send this with the actual SKIE, and it will, work as you expect. So again, okay. And this is going to send it once. That's all it's going to do. Again, cancellation is supported. So if you call something and leave and you're in the right context, it'll shut it down in the way you would expect. Although I would say one caveat, if you are migrating and your code is written in such a way that you don't expect it to be canceled when the context gets removed, you're going to have to be aware of that. So the more dramatic part of the demo is showing you what happens when you call it on a different thread. And this is kind of one of those things that I'm not sure how aware everybody is. But if you call a suspend function that comes out of the Kotlin compiler with just whatever comes raw out of the Kotlin compiler and you set it to another thread, you're going to crash. And one of the things that our iOS experts have assured me is that in development, like you don't really generally control the threads run as directly as you might in other contexts in Swift. The platform kind of handles a lot of it, and it might optimize things at runtime that you wouldn't necessarily get in development time, or you make it a surprise, so you might get some weird surprise crashes. So there are issues with using that anyway. Just to show the more dramatic part of the demo. Oh no, and we'll click this and we're gone, right? What a bummer. But we'll do this and do it again, and you can guess what's gonna happen. And this is always the last part of the demo where I'm like, I hope it doesn't crash for some other silly reason. It did not. Okay, so yeah, blah 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 blah. Well, yeah, that's essentially it. I need a better landing on the demo, but that's what the demo does, and that's what SKIE does. So we're going to open up for questions. Please put them in there. I am a little bit delayed, I think, in what shows up on the stream and the questions that I get. So let's see. Tyler, is there a minimum iOS requirement? I'm going to back channel while I do this. But there is definitely minimum requirements. I'm going to say it's probably in the docs, but I can't look at that while I'm doing this. It certainly, I would say there's a minimum because async has a minimum. But then even if you're not using async, I believe we do. I'll wait for that answer. It's not, I don't believe it's super high, but if you're, there are a handful of folks who need to maintain extreme backward compatibility, and that might be an issue. What was the URL to the GitHub repo? I will get you that. Already answered in the chat. Yes, you did. See, you just got to keep reading. The GitHub repo is SKIE demo sample, but I will post that in the chat. Okay. And that's there, I think. Here we go. Some more things. All right. I'm not very aware of the Swift. Could you tell me more? What is the issue using default values? So it's I mean, the problem is simple. In Kotlin, you can just put a default here, right? And it'll work. And then if you go to Objective-C, this is something that Objective-C is completely unaware of. So they go away. So you have to supply all of your defaults explicitly. And I think, if you think about it like, well, that's kind of a nuisance, but it can be more than a nuisance if your function, the default maybe you have in a function changes and your application does something different if you're calling it with a default, which is probably not a great design, but it's still possible. We wanted to introduce default support because, obviously it's good. And honestly, it was one of those things that we decided was going to be easy. Or I thought it was going to be easy. I thought that was going to be the easiest thing of the bunch. And it turns out that while Swift and Kotlin both have default arguments, they are quite different in subtle ways. I won't really go into it here, but the summary is that we couldn't just, make extension functions and drop them over there, if without dealing with the edge cases. So what is happening now is we generate extra functions to provide the default argument support to Swift, but it is something that if just applied globally is, again, it can be a problem because it's going to generate a lot of functions and add compile time. And we did some extensive testing before we released, and there were a handful of code bases where they applied SKIE to everything, and they had a huge code base and they were exporting everything, including like truckloads of data classes, and that was creating an issue. So we have that off by default. You have to put it on specific things you want to use, and we are discussing possibly like, there's a lot of happy paths where the Swift version would be fine, and then it's the edge cases where it kind of doesn't work. So we're talking about ways to get around that, but it might be one of those features where you just have to be aware of it. But that's what default arguments does. It reintroduces. You don't have to pass this in. It's a relatively simple concept that has a added implementation that takes a little bit of extra explaining. Yeah, so I think that's. Well, I'll keep watching for questions, but I will riff a bit. We released SKIE. Again, SKIE was an enormous organizational effort. I mean, it's not just a handful of folks. And in the wake of that, we immediately had DroidCon, and then now that that's done, we are back to catching up with a lot of our other open source stuff. So we had a couple. A few big releases of things that have been, we've had release candidates of version 2s for multiple libraries for like a year. They're finally out. And then today or tomorrow, most likely tomorrow at this point, we're going to release an updated version of Cambridge, which is our packaging and deployment tool. And next week, same time, hopefully we don't accidentally start the stream early and have to switch streams. We're going to do a demo of the updated Cambridge and specifically using SKIE. And the whole point is to provide a jumping off point for teams that are using KMP. Like a lot of our work is with teams, and a lot of the default tooling is kind of everything is done locally, and the person writing this is also writing the other thing, and there's not a lot of issues that a larger team might run into, and it's a lot of where our focus is. So Cambridge is coming out again. If you've used Cambridge, the initial version, it's a long story. We kind of were doing a lot inside the Gradle plugin, and a lot of that's now extracted out into CI, which is good because it's simpler. But if you have some other CI, then you have to do some extra work. But it's appropriately, I think, responsible for what it's responsible for now, and we'll be putting it up very soon. After that, we are very particularly getting into the lane of, with clients very explicitly, several instances of major clients we've been working with that are producing SDKs internally or externally. So larger orgs may be publishing to other teams, or maybe you have one organization that has a handful of outside partners and they publish things, and we have been doing that quite a bit, and we're formalizing that a bit in training. We have this thing, Touchlab Pro, which you may have seen on the website. It is essentially a premium support access to our team and our best practice docs, and a lot of that is around some of that is around SDK stuff, but then also we've been we're putting out things with Cambridge and some other tools, and then putting out content to support that concept, because it's one of those things you don't really hear about much, but it's like inside various orgs, they're like, instead of publishing to native libraries, they'll try out KMP, and it's worked quite well if you have a good start and you understand, the particulars, and you understand the nuances specific not only to Kotlin Multiplatform but also SDK development in general. So that's a plug for our services. Please reach out. This is something that we do. All right. Descriptive, easy to follow. Thanks. All right. So I think that is it for the questions. Again, sorry about the stream. Last minute switch up, but I will promise next week that won't happen. And then if it does, I'll apologize again. But we'll see how it goes. Yes, we're doing future SKIE development. Anything's happening in public. Some of our test suite is not currently. It's a long story, but it is. That's like the really extensive testing suite stuff. Part of it also is SKIE's rather complicated to add entirely new features. So we've had some folks sort of propose some changes and things like that, and it's not that we don't want submissions. It's just again, when going back to the beginning, if you add one feature and then you have another feature and they're not really extensively tested well together, they can trip each other up in unpredictable ways. So we just released it over time. If people are really eager to add features and do things, please reach out, and then we can give you access to some of the internal testing tools and stuff. But it's a longer story. Calling suspend functions without having to switch to the new memory model. Is there any risk? Oh, the new memory model. You mean the non-strict memory model? There's a question about, because SKIE lists restrictions on threads for suspend functions, is there any risk when the new memory model becomes the default? Like, if you're talking about the strict, it's default. Like, it's been default for a while. So absolutely not. The crashing that you saw was not the strict memory model. That's the current default new memory model. Yeah. No, Thaddeus is saying in there we didn't do anything with the old memory model. We just actually put out Stately as sort of a. This was made for the old memory model. It's kind of in a maintenance release mode. I don't know really too many orgs that are still using the old memory model, unless like you built a bunch of code and you're not really changing it a lot. But yeah, it's gone. I mean, that's amazing how fast it went, but it's pretty much gone. So not only is it not a new problem with the new memory model, I would not try SKIE with the old memory model. Maybe you could. Let us know how it goes. Yeah. So, any other questions, please ask. But I think we'll wrap this up at a nice even hour. And please come check out the website. We have many resources. We should have the new Cambridge release, blog posts, probably tomorrow at this point, but we'll see how it goes. And definitely check in next week where we're going to talk about using that and then kind of putting all this together and building and publishing excellent Kotlin-based Swift-friendly APIs. Thanks for joining.